Right, let's take a look at this problem. Find peak element. Element is an element that is strictly, peak element is strictly greater than its neighbors. Given an integer array nums, find a peak element that return its index. If the array contains multiple peaks, return index of any of the peaks. Alright, you may imagine that nums minus 1, nums n is minus infinite. So you don't have peak there. What's it can be between those. Okay. Here the peak is 5. I'm sorry, 6. This should return in log n time. Okay. I guess log n time. So we have to do some sort of binary search, but let's say that we look at this. We check two sides. When it is the right side is greater, we want to go right. When left side is, yeah. So maybe I should just write the binary search here. So I'll need left, which is 0, right, which is n minus 1. So n is equal to length of nums. Well, left is right. The first thing I want to do is left plus right minus left by 2 if nums mid equal to target, I return mid, else if nums mid, if this is greater than the target, then right should be equal to mid minus 1, and else left should be mid plus 1. So this is the binary search. We kind of have to modify this, and every time the targets should change. At least that's what I think. And so we calculate this. We should check left, right. So which one is greater? We want to go that way. So we return mid if mid value is greater than the nums mid minus 1, and also should be and nums mid plus 1 should be also greater than, it is strictly greater, so nums mid. But the important thing here is that, so okay, actually I have a problem. Let's return 0. But if we have just 1, and 2, okay, there is a case where if you're on the edge, yeah, there are three cases where we are on the edge or not. So, okay. The first thing is that, so I want to have those two cases where if okay, if mid equals to 0 and mid plus 1 equal to that, else if, okay, let's say if this is equal to length of nums, that's 1. If it is on the other edge, like last item peak, first item peak, in these cases, we can return any of them, right? Any of the peaks, alright, so no problem. So first item peak, last item peak, and also else if it means that we're not the first or not the last, so we can check these. Actually, I check it then. So we're not the first, we're not the last. I guess I should go like this. If that's not the case, else what do we return? Where is the first item? What if there is no peak? What if this is like one way? Okay, we don't have that case. We just have different values for and after, so we don't have the case where it is equal. Okay, in this case, we're in the middle. So here we're in the middle, and it means that if this condition holds, we basically return mid. Else we change the target, return at the end. What do? I don't know, maybe not return none, because we should be able to find one. Right, so alright, maybe change this 1 to 2. Okay, test out the cases. System is not defined. My target is always maybe I should do it like this. Because if this is the case, then I want to move to the right. Else, if when this is the case, I want to move left. So, so what happens? Calculate the mid. It is not there and it is not there. You come here, mid minus 1. It is something smaller, yes. Mid plus 1. If that's the case, let's try that. Right, it looks like it's working. Let's submit. What is this? Next out of range. Oh, I forgot to check that. Yeah, if mid is 0. Maybe I should have something like if rather than nums is equal to 1 to return nums 1 is equal to 0. Okay. Alright, that's good. Okay, I feel like I identified all of the cases, of course, but I wonder if there's a clean way of doing this. Probably there is, but okay. Basically checking it like this. Yeah, mine is a bit weird, but I think I can simplify it if I give some more time. But yeah, this is my solution to this problem, and the complexity is log n as required as So yeah, mm, so that's it.